Welcome to chemistry classes by Vijay Kumar Sethi, class 11th chemistry. We will start the next unit, that is unit 6, thermodynamics, and in this video we will discuss some thermodynamic terms like the system and the surroundings, types of the system, state of the system, state functions, and adiabatic system. First of all, what is this thermodynamics? Actually, this is thermo means thermal heat and dynamics means motion, moment. Any process which involve this motion of heat, and as we know heat is a form of energy. That's why the transfer of energy from one form to another form is studied under this thermodynamics. That's why we can say the branch of science which deals with the quantitative relationship between heat and other forms of energies is called thermodynamics. For example, chemical energy stored by molecules can be released as heat during chemical reactions when a fuel like methane, cooking gas, or coal burns in air. The chemical energy used to do mechanical work when a fuel burns in an engine. The chemical energy used to provide electrical energy through a galvanic cell like dry cell. The study of these energy transformations forms the subject matter of thermodynamics. Is that clear? Now see some terms: system and the surroundings. The part of universe in which observations are made or which is under investigation is called system. Surroundings is the part of universe other than system. The surroundings include everything other than the system. System and surroundings together constitute the universe. That's why we can say the universe is equal to the system plus the surroundings. For example, if we are studying the reaction between two substances A and B kept in a beaker, the beaker containing the reaction mixture is the system and the room where the beaker is kept is the surroundings. System and surroundings are separated by a boundary, and this boundary may be real or imaginary. In case of this reaction mixture kept in this beaker, the walls of the beaker constitute boundary. Yeah, you can also, and this is a real boundary. You can also consider as this is system, this is surrounding, and this wall, this is a boundary. And again, this circle represents the universe. Okay, and in universe, system is there, surrounding is there. Okay. Types of the system. First come to open system. Open system is the system where exchange of energy and matter between system and surroundings takes place. That is, both are exchanging energy as well as matter. For example, the presence of reactants in an open beaker. Here, the boundary is an imaginary. Okay, you can just try to understand. This is a beaker. You can say these side walls are the real boundary, but at top of this, when this is opened, we can imagine that this boundary, or you can say this is a imaginary boundary. Okay. Closed system. There is no exchange of matter, but exchange of energy is possible between system and the surroundings. For example, the presence of reactants in a closed vessel made of conducting material. Okay. Next one is isolated system. There is no exchange of energy and matter. It means both energy and matter cannot exchange between the system and the surroundings. For example, the presence of reactants in a thermos flask or any other closed insulated vessel is considered as an isolated system. Now just see these diagrams representing this is open system. Okay. this representing that matter can exchange, and this representing that energy can exchange with the surroundings. This is a closed system. Now this at the top of this beaker, this is closed. Lid is there. Matter cannot exchange in this case, but these walls are the conducting walls. That's why energy can exchange. Now this is an isolated system. Okay, in this case, this is matter and energy. Both are not exchanging with the surrounding. Actually, in this case, these dark lines, this represent the insulated walls. Okay, in general way, you can again compare this open system, saucepan without lid. This is open system. Saucepan with lid, this constitute closed system, and these are thermos flask, isolated system. You are familiar with this type of water bottle. Okay, insulated water bottle or hot water bottle. Yeah. The state of the system. The state of a thermodynamic system is described by its measurable or macroscopic, that is bulk properties. We can describe the state of a gas by quoting its pressure, volume, temperature, amount, etc. We can also define state of system in another way. It is the condition of state which is described in terms of certain measurable properties such as temperature, pressure, volume, etc. of the system. Take one example. If we consider water, okay, and if we are taking its 1 liter at 1 atmospheric pressure, and suppose its temperature is 25 degrees Celsius. Okay, now this is considered as a state of system of water. Okay, and this state of system can be changed. Now, if in this case we change the temperature from 25 degrees Celsius to 35 degrees Celsius and remaining things they keep constant, then we can say we have reached to the another state of system. Is it clear? State functions. The macroscopic properties whose values depend only on the state of the system, it is initial and final, and not on how it is reached, are called state functions. For example, pressure, temperature, volume, internal energy, enthalpy, entropy. These are the state functions. Sometimes these are also known as the state variables. Let us see one example. If any person is standing at this position, this is considered as a state 1 and its height is considered as a 0 meter. Okay, and that person want to go up at this position. Okay, and you can see this is a certain height. Suppose this is a, you can say this is 50 meter height. Okay, this is state 2. Now there are the number of ways by which this state can be changed, and this is one way, that is A, described by A. From this A path, one person go from this to this place. Then this is the B, this one person can go like this, and this is the another way, this is the another way. But after reaching here, okay, whatever the path he selected, the height is 50 meter. That's why we can say this height is a state function. Okay, but whatever the energy a person lost during change of this height, that is heat energy, this depends on the path. Okay, that's why this heat energy is a path function. Then we can say that is a person if select a different path, then he or she will do the different work. That's why we can also say work is also a path function. So what are these path functions? Path functions depend on the path taken to reach one state from another. Okay, I think you must be clear what is state function and what is path function. You can also take one more example. Like if you are standing at the ground floor, okay, and you want to go up to 7th floor of one building. Okay, now two ways are there. One is by stair and another one is by lift. Okay, after reaching the 7th floor, your height, whatever the way you choose, is fixed. Okay, that is, you have reached to the 7th floor. But if you go by lift, work done is less, and if you go by stairs, work done will large. That's why work is a path function, while this height of that building from ground floor to 7th floor is state function. Is it clear? Adiabatic system. The system which will not allow exchange of heat between the system and surroundings through its boundary, but energy of the system may change by work. Remember it. Energy can be changed, but there is no change in heat. Okay, and this energy can be changed with the help of work. That system is known as adiabatic system. Adiabatic process is a process in which there is no transfer of heat between the system and surroundings, and the wall separating the system and the surroundings is called adiabatic wall. For example, bursting of tire is an example of adiabatic process. Actually, this bursting of tire is taking place so fast. It happens so fast, there is not enough time to exchange heat with surroundings. Okay, but in this case, work is done by the system. Clear? It's why with the help of work, energy can be changed, but heat will not exchange with the surrounding. You can see this diagram. Matter is not changing and energy is not changing. Sorry, energy can change, but this heat remains constant. Okay, no change in the heat. An adiabatic system which does not permit the transfer of heat through its boundary. I think this is clear. What is this adiabatic system? Now, what are the differences between adiabatic system and isolated system? It has no exchange of energy and matter with the surrounding environment. It has no transfer of energy and matter through its boundaries. In case of adiabatic system, it has a surrounding environment. But in isolated system, it does not have a surrounding environment. In case of adiabatic system, it does not gain or lose energy, but internal energy can be changed due to work done by the system. But in case of isolated system, energy is conserved. Adiabatic system involves internal energy can be changed, while in case of isolated system, internal energy cannot be changed. Okay, thank you. Subscribe my channel to get the new videos from this chapter.